Hello, everyone. Good afternoon. By way of introduction, I work at a company called Victara. I had developer relations. And I was fortunate enough to work on LLMs quite early, more than most people I meet these days, since 2019, and since GPT was at version 2. So it's been really interesting to see the kind of progression of how this technology evolved. And I want to tell you a little bit about my journey to today, but focus on this topic of LLMs and why they hallucinate. So many of you have seen examples of this, I'm sure, but this is one of my favorites. If you ask GPT, did Will Smith ever hit anyone? Of course, the answer is no. He's a pretty good guy, generally speaking, until they see this, right? So ChatGPT does hallucinate, and this, one example of many. And although these things are being fixed over time, it's still a big problem. So what's a hallucination? There's a lot of people who say that actually the word is not a good word, like call it fabrication, call it hallucination. Personally, I don't really care what you call it. It's just the notion or the concept is what matters. I think hallucination has taken over. But generally, it's when you ask a generative AI model or a large language model to generate content that is either incorrect or, as the case may be, unfaithful to the provided source content. And I'll give you examples of this in a minute. So why do LLMs hallucinate? What's really behind this? And to do that, I want to give you a conceptual paradigm to think about. This is kind of abstract. Don't take this too literally. But generally, I like to think of an LLM. You all know it's trained on massive amounts of data. Wikipedia and Reddit and all kinds of things that they put in there, depending on who's training it. And to some extent, there's knowledge that's accumulated in this text that we train it on. And so that knowledge is encapsulated in a very conceptual form of a knowledge graph. Again, I don't mean to say if you worked in data science for a while, you might know that knowledge graph has a particular, instantiation meaning, like a very practical meaning. I don't mean it in that sense. There's no actual graph being generated, but there's some way that the LLM seems to acquire knowledge, and we can know that because when we ask it a question, it gives us, an answer based on some concepts and some knowledge. So we can observe it by asking questions of it. So imagine, for the next couple of slides, that the LLM has some knowledge graph embedded in it, and I'm going to go into the first reason why LLMs hallucinate, which is you ask it a question which is actually not in its knowledge graph. So it hasn't learned that information, and LLMs are not trained to say, I don't know, or caveat their answer. They're, in the pure sense, they are trained to just complete the text that they've seen so far with something that comes after that. And so they will generate the most highly probable responses given the prompt or the beginning of the sentence. And highly probable doesn't always mean correct or true, right? So that's where a lot of times you ask a question that they don't know, that's the response you're going to get. The Will Smith example is a pure example of that, right? ChatGPT, at least the one I asked here, which was 3.5, did not know about this incident of Will Smith. It wasn't in its data set because it happened in 2022. And so it just responded with whatever it knew. And it happened to be wrong because it didn't have that information, right? The second reason is actually quite simple to understand too, which is that the information that led to building its knowledge asset could have fictional content and could have or incorrect content, or more often than not too sometimes subjective content that you may not agree with, some opinion or some information or belief that you don't agree with. And those are the two main categories I want to mention today of why LLMs hallucinate. Now, if you read the research papers, there's a lot of other people who do 5 categories or 15 categories, and there's a lot of other attempts to sort of describe it in different ways. But to me, those are the main ones that I think they cover, for the most part, all the things that we care about. Now, an interesting thing to note is that it's really important to evaluate hallucinations. So how do you solve hallucinations? The first thing is you need to understand if it happens. And I'm putting a little plug here for something that we launched about 2 weeks ago, I believe, which is called the hallucination evaluation model. And what it is it's a model that evaluates LLMs and how much they hallucinate. And you can see here, this is an open source model, so anybody can use it and run it on other models and understand how much they hallucinate. But we've done it for a couple of models shown here, anywhere from GPT-4 to Google. And surprisingly, they don't all behave the same way. They don't all have the same properties. So if you're interested in learning about this more, you can look up, the model is again, open source, accessible to anybody on Hugging Face, and I invite you to try it out as well. Okay, so now that we know what hallucinations look like, why they happen, and there's at least some way to measure them, how do you address hallucinations? How do you solve them or address them or figure them out? So I'm going to talk a little bit about research that's going on. There's a lot of research in this. This is by no means comprehensive, but I want to mention a couple of different areas that I've seen of people tackling this. The first one is improve the training data. So, for example, you can say, if I know that something is actually really incorrect, not an opinion or belief, but incorrect, I can remove that from the training data. So there's a lot of areas around cleaning up the training data to make this a little bit better. The most well-known second technique is called RLHF, or reinforcement learning from human feedback. That's famously the technique that OpenAI used when they trained GPT-4. Now, a lot of other people do that, the same thing. Essentially, it's a way to collect human feedback and incorporate it through reinforcement learning in a very useful way to help the model do better with this. Quite complex, quite expensive to do, but very effective in a lot of ways. And you've seen this in the leaderboard too. There, like GPT-4 is kind of high up there. And then there's people tackle it also from the prompt engineering side. So improving the prompting, and there's research papers around chain of thought and tree of thought, React. There's a couple different approaches. So again, you can read about those. I just wanted to mention them. I'm not going to dig into those here. The most common technique, though, to address hallucinations, especially if you build applications with LLMs, like ChatGPT for your own data kind of applications that we all heard about, is called RAG. And I want to talk a little bit about RAG today. One, because that's my day-to-day, that's what we do at Vectara. But also, it's become a really common technique, and it actually solves a lot of really interesting problems. So what is RAG? Well, we used to call it, by the way, at Vectara, grounded generation. We like that term because GG is also a gamer's term, and it's really cool, but we lost that war. Now everybody calls it RAG, so RAG it is. But RAG is essentially where instead of taking a query, running it through the LLM, and getting a response, you instead have some custom data, your own data, your private data, and you augment the LLM's knowledge when the user submits a query with additional facts from your own data that you retrieve from the data. So it helps reduce hallucination, and it's very common flow of building applications that are generative in nature. Let me go a step further and show you this. So if you build your own RAG flow, which many people sometimes want to try, at least when they try out to sort of figure out how to do it, this is generally how the flow looks like. So you start with some data source, and it could be anything, but people do 1 PDF to 10 PDF to a website or documentation website or something in a database or whatever the data source may be. It could be like a single file to millions of documents, right? And the first thing you got to do is you process the documents. You extract the text from the document. If it's let's say a PDF, you have to remove the binary and just extract the text. You do something called chunking, which is splitting the text into smaller chunks of text. And you run this thing called an embedding model. So embedding will take every chunk of text and convert it into a vector of usually maybe 1,000 different values and float. And this vector represents the semantic meaning of that piece of text. And then you put it into a vector database. You also have to put the text into a text storage mechanism of some sort. And then that's the ingest flow. And then when you run a query against this, so imagine you have done this for 1 million documents here, and now somebody issues a query. You embed the query itself too, to get into that embedding space. And then you run it against the vector store mechanism with similarity search to get the most relevant facts that answer that query. You construct a special prompt and send it to an LLM like OpenAI or Cohere or one of those, and get the response. And the prompt here is, simply something along the lines of, here is the question, here are some facts related to the question. Mr. LLM, can you please respond to this question based on these facts? That's what we call it, grounded generation or augmented. It's more complicated than that, but that's the high level, the gist of it. I also want to mention here that there's some work starting to happen around action, which is, oops, I move. After you get the response, sometimes you say, oh, let me open a Jira ticket based on that, or let me do some action in the enterprise based on it, if I trust that the response is good enough. So this is generally how RAG works. And, what we do at Vectara is essentially this. We put it in a box. So what Vectara does is essentially, we call it grounded generation, but it's RAG in a box, if you will, where we simplify all these things for you. So if you want to build it yourself and you have a team of MLEs that want to do it and continue to maintain it and make it secure and make it scalable, then you can do it yourself. But we also help people who want to focus on their business and want to outsource this complex task to someone else. So all you have to do is index the documents and run a query, and everything that I showed you in the middle kind of gets done on its own. So you don't have to worry about that. It turns out that's pretty helpful for a lot of people. So to summarize, why is retrieval augmented generation useful? Again, you can augment the LLM with your own data to reduce hallucinations. The data is private. There's no training here. A lot of people ask me about fine-tuning or training. No training is being done. It's just storage and a very complex retrieval, but there's no training. So the data is not used in any other way. It's very inexpensive to implement and use relative to, for example, training or human feedback collection. And as the LLMs improve, this improves too. So if you get longer sequences or you get better performance, less hallucination, everything improves in the RAG flow as well. Okay, so a couple of things about doing RAG right. And again, this is kind of highlighting a few of the things that we will do for you, but I wanted to share a couple of the hurdles if people here want to do it themselves, like what types of things you might run against. It's not comprehensive, but a couple of things that I hear a lot. RAG is all about the R part, the retrieval part. If you do the retrieval wrong, you're going to get bad results. So you can get low recall, which means there are facts that are in the data that you're not going to retrieve, and then the LLM just knows what you tell it, so you won't be able to use that piece of information. Or it could be low precision, where you just bring in wrong facts, and then it poisons the LLM's knowledge or augmentation, and it produces bad results. So you kind of want to do both in an optimal way as much as possible. So one thing people talk about is called chunking. So if you don't know, this is what chunking means, is you have a piece of text that's pretty long. This is the 2022 State of the Union text that happens to be somewhat popular in this space for some reason. So you can do something called fixed chunking, which says I'm going to count, 500 characters, and then another 500 characters, just chunk it this way. Turns out to be not that great. What ends up being more useful is to do some kind of NLP chunking, really split it into chunks of meaningfully consistent, little sentences or paragraphs, right? Because remember, you take these chunks and you encode them into vector embeddings, and if the vector embeddings have stuff from multiple sentences, they might, have a confusing semantic meaning in them. And then when you feed the chunks into the LLM, so imagine you did that, you did the right chunks. Another thing that people do that's very common these days is the ability to take the chunk that matched. So when I run the query, I match it against this chunk. And then I can add some context before and after fitting into the LLM. So the chunk itself has to be pretty small because you want it to have a very clear and precise signal of the semantic meaning. But you can add a couple sentences before and after to give the LLM a little more context when it tries to decipher the fact that you're giving it. And that's actually works extremely well as well in practice. And I passed here, but you can. There's a whole blog post you can read that I wrote more details about this if you're interested. And then the embedding model is also important. So embedding models, there's many that are open source. There are some that are commercial. And not embedding models, not all of them are created equal, as said here, but essentially they take a chunk of text, like shown here, and as I said, they convert it into an embedding vector. And the better this vector represents the semantic meaning and can answer questions and match against questions, the better your ability to fetch the right context, the right text, and feed it into the LLM. So again, there's a whole blog post about this, but at Vectara we recently did some significant work about this in a model called Boomerang, which, as you can see, is almost equal, if sometimes even better than Cohere and OpenAI as a model. I should say that Cohere since then launched a different model, a version 3, which is kind of really what we were hoping for, because we want to almost like light a fire in the industry that creating better embedding models is actually good for everybody. So let's work on that, because a lot of the work has been focused on sort of the summarization, the chat models, and the embedding models need more attention. So so thank you for that. All right, so those are two things. There's other challenges that people face and have to make decisions, and this is why we wanted to put in a box, so to speak, all this complexity to make it easier. Final thing is I want to show you a little bit of an example. I'm going to click on this and see if this works. So this is a sample application. What do I mean by a sample application? This is an application we built with Vectara, like a customer of ours would build. So we don't want to sell this application. We just build a couple of examples for people to see what you can do with it. And in this case, this is a fun one that crawls. We can't show you private customer data, of course, so we have to show some public data. So instead of doing private data, we crawled news articles from different sources here. You can see from the BBC, NPR, Fox, and CNBC, and CNN. And there's a couple of questions you can get asked here. And when you type in or click one of these questions, what happens is the query goes to our system, to our query flow that you've seen before. And what you get is you get a summary response, which essentially is the response to your question, right? This was, should AI be regulated? And the answer here is AI regulation is a topic of debate, with some arguing for its necessity, et cetera, et cetera. And as you can see, we also have some citations here. So if I want to see, okay, this particular part of the response was based on this particular citation, so I can go here, and if I choose to, I can go in here and kind of click on this and further investigate, if I feel like, maybe it's, I want to dig into this a little bit more. This ability to provide us citations is actually really helpful because it creates a much better sense of trust, right? It's not just a response and you don't know where it's coming from. You actually have the ability as the user, as the reviewer, to look at this and see what happened here. This, of course, is nice because you can actually also change the language. So, for example, I can have the response in, I don't know, French, let's say, and I can't read French, but if somebody in the audience can say if the result will be meaningfully the same, then I think it'll be okay. But it can respond in French. So, again, even though the original text is in English, the response will be in a bunch of different languages. Okay. So there was, oops, I clicked on this again, sorry. I have to click here. And that was the demo I wanted to show you. Thank you very much for listening. If you are interested to learn more about Vectara, we have a couple of resources here. We have a free account, so you can try it out to see if it's useful for you. Documentation. We also have integration with LangChain and Llama Index, which are great partners for us. And if you're a startup and if you're part of a startup, we have a really nice startup program as well they can sign up for, and you get some good benefits. And with that, if there's any questions, maybe? Hold on a second. I apologize. Yeah.
Thanks. There was a previous talk by Baruch, I believe. He was talking about GPT plugin. Is it doing RAG behind the scene?
GPT plugin, you probably mean GPT builder, like GPTs, the new release.
He mentioned plugin. I understood
Plugin.
it's something very abstracted where you basically just provide your own data source, which looks very much like RAG.
So most people ask me about the new released Dev Day, 2 weeks ago. It's called GPTs. I think GPT plugins was kind of maybe an older version of that. So both of these things do similar things to this, but they're not meant to be enterprise ready and scalable, at least not now. And so for example, if you look at the GPT builder, it's like you can ingest 20 documents. If you want to do, if you're a student and you want to look at a PDF to prepare for some class and ask some questions, and you have like one PDF, that's great. It works for small cases. That's not to say that OpenAI may not innovate in the future. I'm sure they will, but like right now, it's really meant for smaller cases. I think of it as, if you guys are familiar with like character AI, for example, that's a nice way where you can kind of build your own character and have it know a couple things, and it's really cool. But it's not, for the most part, not meant to be as scalable as this with like millions of documents. Yeah.
And I have one more small, maybe dummy question, but
Yeah.
on your second slide, I believe, before you mentioned RAG, there were other alternatives about working with the prompts and other things. When people refer to fine-tuning, what is it exactly from that list?
So I think your question is like, what is fine-tuning and how does it relate to RAG?
Yeah, you had that slide. I don't know if it's possible. Come back to that. I think it's your second one, just before you start talking about RAG.
Oh, before RAG, maybe.
RAG was very last, and there. So what is above RAG referred as fine-tuning?
I think I may have talked about it. Oh, I didn't mention fine-tuning, but let me talk about fine-tuning. So fine-tuning, generally in deep learning, fine-tuning is the idea that you take a pre-trained large model that was trained by like OpenAI or Google or Meta. That's really hard and expensive to train. And you fine-tune it, you train it a couple more times, a couple more epochs, it's called, a couple more cycles with usually a smaller data set that you create and you provide. So there is a lot of questions I get about, okay, why, if I have my own data, right, I have even $1 million, why wouldn't I fine-tune on that? And my answer to that is, in reality, it's not a great technique to use. And there are a few reasons why that's the case. The first one is that, well, first of all, fine-tuning is much more expensive. Usually it doesn't do what you intend it to do. In other words, you fine-tune it, and it learns more about your data a little bit, but it can also forget a lot of the stuff that it learned in the previous tuning. So you have to be a real expert to do that well. And then, so a lot of times people try to do it, and it doesn't give them what they want. A good example that I'm going to quote from my friend Walid at Anyscale, who posted a blog post about this, and I invite you to look that up, is he trained a model. He took all the works of Shakespeare and changed Romeo to Bob, okay? And he fine-tuned the model on that. And Walid, I think, knows what he's doing too, but in terms of, he's actually got this expertise. But let's put that on the side. So he trained the model on the works of Shakespeare when replacing Romeo with Bob, and then tried to ask questions, and it was still responding with Romeo. So it didn't really learn that Bob and Juliet are now an item. It's just, it didn't learn that. It didn't that. So it's difficult. There's a bunch of other reasons. For example, permissioning is not possible. Fine-tuning control of data. There's a lot of other reasons I can get to in here, but I'll have to answer maybe later on if you're interested. But generally, at this point in time at least, fine-tuning ends up being not the best technique, as far as we see. Yes?
What's in a name?
What?
What's in a name?
Right, exactly.
Exactly, thank you.
You mentioned NLP chunking. Would you mind just walking us through a little more detail about exactly technically how that works? And the second part is, is your company one of the few groups that's doing NLP chunking, or are the, other competitors doing it as well?
Yeah, so great question. So NLP chunking, what it is, it's essentially what you kind of see here, which is like you try to use NLP techniques to split into either a sentence or a couple sentences, whatever. It's a little bit more tricky than just a single sentence. And by the way, do it in any language is also kind of tricky to do. But generally, that ends up being the chunks become small enough and usually have a consistent sort of semantic meaning. And it turns out that works pretty well in practice. Now, to answer your question, who else is doing this? I'm not aware of NLP chunking per se, but I know that our friends at LangChain and Llama Index, for example, have started from a simple implementation like fixed chunking like this. And then there's been token-based chunking, which works a little bit better. And then there's been hierarchical chunking. So they're continuously improving. And I think they do have, both of these projects have something that's somewhat similar, not exactly NLP, but one is called, I think, parent document chunking. And there's a couple other techniques that are kind of gravitating towards NLP chunking, at least in practice, and are closer. And yeah, again, because it provides better outcomes.
Okay.
Yeah.
Thank you.
Of course.
Yeah, I wanted to ask about that hallucination evaluation model.
Mm-hmm.
How do you measure like hallucination, or like how this model works? I was just curious.
Great question. So generally, and I'll say a little bit of that, and I think there's more, again, description and better than I could say in our blog post about this. But generally, the way we measure hallucination is, you say, again, it's in the context of RAG system. So I give the model, it's a model that measures hallucination. It's been trained as a model to classify whether a response of an LLM is a hallucination or not, based on the facts that you provide to it, right? So you give it a bunch of facts. So there's a data set, and you measure against this data set. So if you bring any other model, you can use that. You can run a set of questions or sets of. There's a data set that you can see that has a bunch of facts and a summarization, and you see whether the summarization of the LLM that you test against gives you the right response or not. This is pretty new. I think we see a lot of interest from it from the industry, and we're looking forward to collaborating with others to make this better. Yeah.
Okay, over here. So as you sort of narrow the focus of these models so that they're only really looking at the reasoning behind things, like more or less you just provide every piece of context that's necessary, and then it will generate its response off of that. One of the weaknesses of our models right now is how wide they are. Like, they're many multi-purpose and also very hard to run because of that. So it would stand to reason that as you start to offload some of this knowledge that the model retains within itself off to like a normal search engine, that you could reduce the model size and make it easier and cheaper to run. What do you think of next steps on that?
Okay, well, great question. Thank you for that. I agree very much with that notion of, LLMs, maybe let me rephrase what you said to the audience in a little bit of my way, which is GPT-4 is great, but it's encompassing so many things, and it's doing so many things in one model. And I think what we find is that it's sometimes, can't do stuff that we wanted because it's like taking so many roles. And so we're offloading a lot of the work to something we know how to do really well, which we've done in the last 20, 30 years, which is retrieval. Let's do that well and let the LLM focus something that it knows how to do well, that may be even smaller. And as you said, could be done faster. Like, we know that Mistral 7B is a pretty good model, and much smaller, you can run it on your own machine. So I definitely think that's a trend that we will continue to see, is models that are not super capable. They don't do vision, and necessarily don't have to do all this kind of stuff. But they're very good. They're small. They're fast.
Was
and
that Mistral 7B? Is that right? Mistral?
That's one that I refer to. Yeah, but,
Got it.
Or any other. There'll be others, right?
What do you think is making that one hallucinate just a little bit poorly? Like, what do you think are the directed efforts to correct that? Any ideas?
I don't know.
Okay,
I don't
interesting.
know. Remember, a lot of these models, people talk about them very knowledgeably. We don't know a lot about these models yet. There's still a lot to know, a lot to learn. It's still a little bit of a black box. And I think the amazing amount of research that's being done is progressing and measuring something that's better. But if you ask researchers, they don't exactly know why this has become better. To explain it very specifically, it's just we've tried a bunch of things and this actually worked much better, right? So that's kind of, unfortunately, we don't know.
Any other questions? I'd actually like to know how long the small dog is going to last on Mars.
Sorry, say it again?
I'd like to know how long the small dog is going to last on Mars.
The small dog?
You had a question in Ask News was,
Oh, yeah. Don't know. By the way, this is a new update of the model. By the way, we just added GPT-4 Turbo, which is the new one that came out. So you can, I think, when we launched this wasn't it. So you can see that. Yeah.
okay, so let's say, no question, okay. Yeah, say thanks for Ofer.
Thanks for listening.